In 1735, the mathematician Euler studied a problem based on the bridges of the Prussian town Königsberg. The town was divided into 4 parts by the river Pregel. 7 bridges connect these sections to each other, and he was interested in seeing if he could formulate a path that crossed every bridge, but only once.
We took a trip to Königsberg to see if we could get from here to here to here to here to here.
We soon discovered that it was impossible, as Euler did. Behind this problem is the idea of graph theory. Lucy, here on the board I have drawn a simple graph. Now, your challenge from me is to draw around it without taking the pen off the board and don't draw around one line twice. Can you do it?
Yeah, easy. Oh. Can't do it.
Okay, Tapali, giving you a different graph but the same problem. Can you draw around this without taking your pen off the board and not drawing a line twice?
I'm not so sure, miss.
Well done, Tapali.
Thank you.
Whether a graph can be drawn or not depends on the number of vertices with an odd number of edges. Here you may have observed that the graphs which have more than 2 odd vertices can't be drawn in the way that we want. For the explanation, we have to look at one individual vertex and see what happens to it as we connect the vertices of the graph. Here you may have observed that 2 of our vertices have 3 edges, which is an odd number, whereas the rest of them all have an even number of edges. Therefore, by starting and ending at these 2 points, we can traverse the graph, and it is possible. However, here we have 4 points with an odd number of edges, so traversing this graph is impossible. As we can see, the Königsberg problem can be formulated into a problem very similar to the simple graphs we saw before. More than 2 of the vertices have an odd degree. Therefore, we cannot solve this problem as Euler discovered many, many years ago. A concept that many of you will probably be familiar with is social media. We can model the idea of Facebook friends by using graph theory. Every person is a vertex on a giant graph, and if they know each other, there is an edge between them. As Facebook is so widely used, one theory states that you are on average 6 edges away from anyone else on the planet. So, for example, Lucy and Jasmine live on the other side of the world, yet they are only 6 people away from knowing each other.
Hey, I'm Lucy, and I want to see how many people it will take to connect me to a randomly selected person from the other side of the world. Last summer, I met a girl called Gladys.
Hey, I'm Gladys. Last summer I went to a summer camp and met a girl called Lucy. She was so funky. And then this year, I met Jerry Halliwell. The Jerry Halliwell.
Hey, I'm Jerry. I met Gladys at a musical festival last year. She was so cool. I was there with my manager, George.
Doors closing.
Hi, I'm George and I'm Jerry Halliwell's manager. I did some business with a lovely woman called Penny last week.
Hello, I'm Penny, and one of my 5 Facebook friends is my granddaughter Jamelia.
Hi, I'm Jamelia, and my grandma's Penny. Last summer I went on a school trip to India, and Jasmine looked after me, and she was really nice.
Hi, I'm Jasmine.
This is one of the topics we covered in our Maths A level. We enjoyed it, and so did you.